Hey everyone, it's Mr. Walker here, and welcome to another math lesson with Mr. Walker. So today we're going to be connecting a few ideas, right? We've been working with volume a little bit. We've been building shapes and decomposing shapes and looking at the layers of these rectangular prisms and kind of being able to like break things down and really see what the volume of them what the volume of these rectangular prisms are by taking them apart and counting the cubes, the cubic centimeters and stuff like that, which has been great. Today what we're actually going to do is we're going to start to see how we can use multiplication to calculate the volume. Instead of having to count up all the cubes or build the shape or something like that, we're going to see what the straight up strategy, what the straight up formula is for finding the volume of rectangular prisms. So it's kind of exciting. We're like taking it to the next level. We're moving from like the hands-on modeling kind of things into the mathematical equation. So I think we're going to have a lot of fun with this today and definitely be building up our knowledge base as we move forward. So you don't need too much today. Something to write on and something to write with would be great. If you have some rectangular prism building blocks, if you want, like those cubic centimeters, if you still have those, you could still use those to start off to make some sense of things, and then you're going to need some sort of recording sheet, which should be available in the module. So make sure you have those things gathered up, and once you do, click continue and we'll keep going. Alright guys, before we jump right into this today, I want to review a little bit of a topic with you, which is area, okay? And we know that we could find the area of a rectangle or a square or whatever it is, as long as we have the measurement of two sides. So let's say like this is 2 centimeters and this is 4 centimeters. To be able to find the area, we just have to do 2 times 4, and that's going to tell us like this space in here, right? How much space this two-dimensional object takes up. Alright, and it's important that we understand how area works because we're actually going to use that to kind of move forward with our understanding of volume. Okay, so we know that we can find area by multiplying the two sides, right? If I were to think of this in terms of like cubes here, so this would be 2 and this would be 4 going this way. Right, so I'd have 1, 2, 3, 4, 5, 6, 7, 8. So this would be 8 centimeters squared because it's only two-dimensional. Or we know that if we did 2 times 4, we would get 8, which is the same thing, 8 centimeters cubed. So hopefully we remember what area is and that makes sense to you, because we're going to use that and apply that in what we're going to do next. Alright, so here I am with my three-dimensional shape here. And I'm going to use this shape to kind of make some connections with what we know about area, what we've done with volume so far, and to start to figure out what kind of formula we can use to figure out what the volume of a rectangular prism would be. So let's start to think about this shape for a second here and what we're seeing. So if I look here at just what I'm able to see, I can see that I have 2 centimeters, or 2 cubic centimeters here, right? And over on this side, I'm going to have 1, 2, 3. So I'll have 3 centimeters, 3 cubic centimeters going that way. And then if I were to count up here, I would have 1, 2, 3, 4. So it's basically 4 cubic centimeters high. Okay, so that's easy enough to see. So I can kind of talk about the length, the width, and the height of this rectangular prism without having to like break things down or anything like that. But let's go ahead and break this down for a second, and let's think about what each layer would be made up of if we were to like kind of separate these layers out, right? Take off this first layer here. Okay, we kind of put it over here. What would it be made up of? How many cubes, or what would the area, if we want to think of it that way, what would the area of this layer be? Well, the area would be 6 cubes, right? Because I would have 3 going this way, 3 cubic centimeters going this way, and I would have 2 cubic centimeters going this way, and if I count them up, 1, 2, 3, 4, 5, 6, and 3 times 2 is 6. So if I used the area, 3 times 2, that would give me 6, or if I counted up the cubes, that would give me 6 as well. Just to kind of like make sure of that, let me just move this shape around a little bit here. We could take a look at the top of it. Okay, and we would have 1, 2, 3, 4, 5, 6. Okay, so there's 6 cubes in that one layer. Then if I were to come back down this way, well, how many layers do I have? I'm going to have that 6 cubes. I'm going to have that 1, 2, 3, 4 times. Okay, So again, we could kind of think of it as, well, we had to do that 3 times 2, right, to get that area, get the area up here on the top. We had to do that 3 times 2, and then we had 4 layers. I was going to put this in kind of like a table here, kind of like what we saw in previous lessons. So this would be our cubes in each layer. This would be the number of layers, and then this would be the volume. So if I had 3 times 2, or 6 cubes in each layer, and I had 4 layers, well, that would give me a volume of 24 cubic centimeters. Okay, so that's one way we could decompose this. Is there another way that we could decompose this to find the volume? So far we kind of looked at like this layer here, right? This layer here, and found the area of that and then multiplied it by that many layers. Is there another way that we could decompose these layers and find the volume that way? Sure, if we went kind of like this, right? Let's say we took this piece right here, kind of sliced it this way, right? Then each one of these pieces, if we were to kind of look at like the side view here, each one of those pieces, or slices, or whatever you want to call them, would look kind of like this. So we could say that they are 2 by 4, right? So 2 times 4 would give me my area of 8. 1, 2, 3, 4, 5, 6, 7, 8. So it's going to tell me what this layer is. So 2 times 4 would give me one of those layers. Now that would be 8, but I have 3 of them. 1, 2, 3. So I'm going to have 3 of those layers. So 2 times 4 is 8 times 3 would be 24 centimeters cubed. Same thing, right? Can you guys start to see like a formula that I'm kind of working on here? What is it that we're actually doing? Take a minute, think about if you're seeing like a formula start to develop, a kind of like a pattern that we can use every time, multiplication wise, to figure out the volume of a figure. Okay, I think I heard some of you saying some things. Basically, what we're working on here is if we could find a length, a width, and a height, or a layer, and then the amount of layers, that's going to tell us what the volume is. We're going to get to the straight up multiplication part in a second, but let's see if there's any other layers that we can find in this particular shape here. The last one that I see here is if we were to split it kind of like, sorry for my wavy lines here, but if we were to split it this way, right? So like two slices here. So we would have like this part right here in the front that would count as an area of 1. So let's see, we have 1, 2, 3 blocks going across this way. We have 1, 2, 3, 4 blocks going up, and then we have 2 of those layers. So really we have 3 times 4, which would give us this area, which is 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. All right, 3 times 4. But then we have 2 of those layers, one here in the front, one here in the back. So we have 2 of those, and 12 times 2 would give us 24 centimeters cubed. So you could see that there's different ways, again, like we kind of did in a previous lesson, of decomposing this rectangular prism. And no matter how we decompose it, as long as we're counting our layers and everything appropriately, we could still find that volume, right? We can also start to see that we are kind of finding the area of one layer and then multiplying that by the amount of layers that we have. So here we found the area of this layer, which was 4 times 3, and then we multiplied it by the amount of layers that we had. All right? So it's kind of like here we had 2 copies of the 4 times 3, right? 2 copies of the 12. In the previous one, we had 3 copies of the 2 times 4 area or array. And then in the first one, we had 4 copies of the 3 times 2 area. Alright, so you might be thinking, what are we getting at here, Mr. Walker? What's your point of showing us all this? So I wanted to make that connection of the decomposing of a rectangular prism, right? How we could break down the rectangular prism and we could add up the different layers that we have and how many cubes we have in each layer to kind of get our answer, to get the volume, right? And we were able to see that basically when we're doing that, we're finding the area of one of the layers, and then we're multiplying it by the amount of layers that we have. And no matter how we kind of stack those layers or how we decompose those layers, our volume is going to be the same every time, okay? So even though we might get to a formula that has us look for certain measurements, as long as we find those measurements, it doesn't really matter the order that we put them in, because we know when we multiply we can switch those numbers around and different things like that. So here's what we're getting at, right? If we look at this rectangular prism again, we have 1, 2, 3 as a length, let's say. We have 2 as the width, and we have 1, 2, 3, 4 as the height. So we have these 3 different numbers going on here, and you can see those numbers repeated throughout the work that we did up here in this table. 3, 2, and 4, 2, 4, and 3, 3, 4, and 2. Doesn't matter, but we have each of those measurements here. And if we take those and multiply them, we are going to get that 24 every time, no matter what order we multiply them in. Okay? And what this is telling us is our volume. Alright? Every time it produced the volume. So we could think of the volume of a rectangular prism as the length times the width times the height of a rectangular prism. The length times the width times the height. Now, if you're not sure which one is the length and which one is the width, I mean, the height is pretty easy to find most times because that's how tall it is. Length and width could be a little bit confusing, but what we've seen is that it doesn't really matter. It doesn't matter because those numbers can be transposed, they can be moved around in our order because we're multiplying. So as long as you have your 3 measurements, if I do 3 times 2 times 4 or 2 times 4 times 3, it doesn't really matter as long as I have each of those measurements going on there, okay? But this is what we found for this example. So let's see if that holds true if we take a look at another shape, another rectangular prism. Let's see if we get the same results. Alright guys, let's take a look at another shape real quick, another rectangular prism, okay? And this one's very similar, except that we're kind of missing a layer here, but I want to just see if the same kind of thing holds true, right? So here I have this rectangular prism. Let's take a cruise around it a little bit. It would be easy enough for me, since I could see this shape in 3 dimensions here, it'd be easy enough for me just to count up all the cubes, right? So I could say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, come around the back here, 14, 15, 16, 17, 18, right? So I would have 18 cubes. So I would know right off the bat that this is 18 cubic centimeters. So that's easy enough if I have this in 3 dimensions and I can move it around like that, but that's not always the case, right? So let's see if we can use that formula like we used earlier, that way of thinking that we used earlier to figure out the volume of this 3-dimensional shape here, this rectangular prism. So let's start to think of this shape in terms of layers. So I'm going to start by kind of dividing it this way, okay, and having these 3 different layers in here, 1, 2, 3. But first I'm going to find the area of one of those layers. So the area means kind of like the length times the width, right? We know that. So here I have 2, and on this side I have 3. So the amount of cubes in this layer would be 2 times 3, right? Which would be 6. Okay, and then I have 1, 2, 3 of those layers, which should get me to, oh, I didn't write down before, I had a volume of 18 cubic centimeters when I counted them. So let's see if that reigns true here. So 2 times 3 would give me 6. 6 times 3 would give me 18. Perfect. 18 cubic centimeters. So that holds true so far. Let's look at if there's another way I could break these, decompose this. Okay, I could kind of do this this front to back way here. All right, and if I were to find the area, I would know that this would be 3 and 3, right? 3 cubes going this way, 3 cubes going this way. That was a horrible color to pick. Try something that stands out a little bit more. There we go, 3 and 3. Ooh, now it's like a Christmas rectangular prism. I like it. Okay, so 3 and 3, so 3 times 3 would be 9. So we know that the area of this layer is 9. So I'm going to write that over here as 3 times 3. Alright, that gives me the layer, and I have 1, 2 of those layers. So let's see, 3 times 3 is 9, times 2 would be 18. Still working out so far, that's awesome. Okay, let's try just one more. I think there's one more way we could decompose this shape, and that would be if we kind of cut it this way, like slices in a loaf of bread, right? This way here. So now I would have 3 and 2, right? 3 and 2, and then I would have, let's see, 1, 2, 3 of those layers, which if I multiplied that all together, I would get 18 cubic centimeters. So the same thing. So I was able to find that volume by decomposing this 3 different ways, but also by just multiplying by those different lengths, widths, and heights. So what we're getting at here is we don't necessarily need to do all that work of decomposing and breaking this apart. We can just think of the 3 different measurements on this rectangular prism, right? Our length, our width, and our height. So if I had this, let's say this is the length here of 3, say this is the width here of 2, and this is the height here of 3. If I multiply these 3 numbers together, I'm looking for that volume, length times width times height. So my volume is going to be 3 times 3 times 2, or 2 times 3 times 3, or 3 times 2 times 3. Doesn't really matter, because when I do that, every time I'm going to get 18 cubic centimeters. Okay, so hopefully this is starting to make sense as far as how we can start to use like a formula now to find the volume of a rectangular prism, even if we don't have all of the actual cubes to count or anything like that, we can't decompose or anything like that, we could still find the volume of a rectangular prism. Let's take a look at one last example. Okay, let's say I had a rectangular prism now, and I didn't see the cubes, right? I wasn't able to go, okay, well this is here, and divide this up this way. Like, I don't have that now. I just have this rectangular prism. But I do know that the length of this is 6 centimeters, and it could be 6 centimeters, 6 inches, 6 feet, 6 meters, whatever. It doesn't really matter. But for this, we're going to say it's 6 centimeters. We're going to say the width over here is 2 centimeters, and my height, let's go with 4 centimeters. So using this knowledge now, I can find the volume of this rectangular prism, because I know, as I've seen in the other ones, if we did have, like if I were to divide this up into 6, 1, 2, 3, 5, 6, and then I were to divide it by 4, and I could do that, and I could draw those cubes in there, but it's not really necessary, because we know that if we do the length times the width times the height, that's going to give us the volume. So I can arrange this as 6 times 4 times 2. I could do 4 times 6 times 2. Or I could do 2 times 4 times 6. It doesn't really matter, because as we saw in the previous examples, as long as I'm multiplying the length, the width, and the height, I'm going to get my answer, because I'm going to get an area of one of those, and then I'm going to multiply it by the amount of layers that I have. So if I were to do this, I would do 6 times 4, that would give me 24, times 2 would be 48, and it would be 48 centimeters cubed. Okay, 48 centimeters cubed. So we can see how we're starting to find the volume there. I'm going to plug in a couple other videos after this that kind of go over this in some different ways, so hopefully help you guys make even more sense of this. But I think you guys are super smart mathematicians, so you're probably picking up on this pretty quickly, and this isn't something totally unfamiliar to you. So as always, please let me know if you have any questions, comments, or concerns. I appreciate you guys watching and playing along with me, and if you need anything else, just reach out and let me know. Alright, great. Thanks guys for watching. Talk to you soon.